Okay, so I chose as my title Darwin in Public and Private, which actually looks a bit naked, I think. Subtitles are almost obligatory these days. So I rather belatedly thought of one. Curiosity, chloroform, and cobra poison. I'd like to spend the last part of this talk this evening exploring through his own private papers one of Darwin's less well-known research areas, carnivorous plants, which includes all of these, curiosity, chloroform, and cobra poison, and actually a whole pharmacopoeia of now banned substances. But also, I thought that this was more likely to keep an audience in the room than calling it 15 years of botanical experiments. So, but I'm going to start by suggesting some reasons why putting Darwin into the context of his private life is a worthwhile thing to do, what we gain from it that just reading his publications doesn't give us. And then look at how we can do that, just what the materials are. Another subtitle I could have used was Tales of the Unexpected. Now, coming up with the unexpected about Darwin may seem like an almost impossible task. He is everywhere. If you want proof, T-shirts, puppets, dolls, cards, Christmas ornaments, tattoos. There's a tattoo in there somewhere. He's one of a handful of scientists who's actually become more of a brand than a person. You probably see him every day when you get your wallet out, because of course he's on the £10 note. He's in the lyrics to rock songs, and if you don't believe me, listen to R.E.M. or Suzi Quatro. And I was thinking of actually offering a prize for the most outrageous movie appearance. At the moment, it's going to the Best Exotic Marigold Hotel. And he recently actually did become a brand. There is now somebody marketing a perfume inspired by his cabin on the Beagle. Given that that was 10 foot square and occupied by 3 young men, one of whom was constantly seasick, I don't know how successful it's going to be. And of course, his name is constantly in the media. And the other thing I had been going to do was just sort of spot what media references I could come up with, the sort of preceding week. And then Disney actually made it ridiculously easy by announcing that they're going to do a Darwin action-adventure movie. So we'll see what that is like. And it's not just the merchandise and the media. Last time I checked, there are actually more than 17,000 books published that have Darwin in the title. So it's very easy to get jaded about Darwin. He's so superficially familiar. He actually has become a caricature, and I think not just the man, but sometimes the ideas as well. And so finding new ways of actually engaging with those ideas is increasingly important, especially now actually in the UK, because Darwin is now in both the secondary and the primary school curriculum. And being presented with a Darwin you don't immediately recognise, with someone who says and does things that you don't expect, with the student, the husband, the father, the friend, and especially I think with the practical scientist, as learning new techniques, wrestling with disappointing results, all the things that you don't get in publications, going down blind alleys. Actually, I think is a very good way of inspiring all of us to look at Darwin again and look more closely at just what his ideas were, at how he was able to develop them, and how he got them accepted. And also, actually, it just puts the fun and the excitement back in. And there's a lot of material that we can do this with. So this is behind the scenes, not at the museum, but at the library. So together with his own extensive collection of research books, Darwin left a huge archive of personal papers, most of which are actually here in Cambridge in the University Library. It's an amazing collection. There are hundreds of books and thousands of manuscript pages. But there's been a revolution in the last couple of years, and you no longer have to blag your way into this building in order to see them. Thanks to collaboration with the Cambridge Digital Library and the Darwin Manuscripts Project, you can now see, and that's at the American Museum of Natural History, by the way, you can now see an enormous amount of the material in that archive, actually online, in high-resolution images for yourself. And there's more going up all the time. And my own project has been involved in that too. So I've picked, just to begin with, just a few examples from the archive that I think particularly illustrate this collision of the public and the private and how valuable it can be. The two events in Darwin's life that tend to be well known are his voyage around the world on HMS Beagle in the 1830s and the publication more than 20 years later of On the Origin of Species in 1859. Now, this is a list that he actually kept. He kept it as a running list during the Beagle voyage. And it is a list to himself of tips and tricks, really, for how to prepare all sorts of different kinds of specimens. I picked, it's quite a long list. He got ideas from all sorts of places, from books he read, but also from many of his friends, and he jotted them down. And I picked this one because can you see it says small at the side? Between the two boxes, if you look at those two lines, it says, small shells to be packed in pill boxes in bran, sawdust, or sand. And it was Leonard Jennings who told him that. And we can go behind the scenes actually in the museums as well as the library, because these are the pill boxes, some of the pill boxes that Darwin actually used to pack shells. The one at the top there had Venus shells in it from Uruguay, so he did what he was told. But I think it's very valuable to remind people that Darwin had to learn how to do things. And that learning, actually, you can see going on throughout his life. Just a couple of years after the Beagle voyage, after arriving back in England, Darwin started recording his observations of a new specimen at London Zoo, their first orangutan, Jenny. A year later, he opened a notebook on another primate specimen. His newborn first son, William. And this is the first page of that. William Erasmus Darwin, born December 27th, 1839, during the first week yawned, stretched himself just like an old person. It's a wonderful mixture, this. This really is a wonderful mixture of the scientific and the personal. Some of it is just the kind of anecdote that any relatively new, besotted parent is going to write down about their child. One son, George, on being asked about reading, said, "I hate reading. I like drawing and money." Nothing to do with science at all. Other entries are more complex because they show how Darwin's work permeated every part of his family life. Another son, Lenny, when he was only 5 years old, found a new grass for his father and apparently said, "I are an extraordinary grass finder," and insisted on taking it to the dinner table with him. But he, at 5 years old, he knew how to find a new grass. And the bulk, certainly of the early entries on William, are detailed observations on such things as when he first cried tears, evidence that he could recognize people, and how and when he first expressed emotions such as fear or affection. And those notes contributed to Darwin's long-term study of emotion, which wasn't published until 1872, and were the direct basis for a separate publication, an article that Darwin wrote in 1877, so this is 40 years nearly later, called A Biographical Sketch of an Infant, which actually is a foundational work on infant psychology. It demonstrates, I think, just how long all of Darwin's research projects were in gestation, or tended to be. And it's something to bear in mind, when faced with articles that get very worked up about the amount of time it took him to publish on the Origin of Species. It took him a long time to publish everything. So as all the stories about the children imply, Darwin was really sort of the original home worker. This is the only workspace that Darwin ever had that he called a lab. It was in the shed in his father's garden, and he was 12. The family home from 1842 until Darwin's death in 1882 was Down House, in the village of Down in Kent. You can still go there today. It's well worth a visit. It was and is an utterly domestic setting. There was never anything at Down that we would recognise as a laboratory. He had a study where he had his books, his specimens, a microscope, and a piece of board let into one of the window embrasures that he used as a bench for dissecting. And I should have slides of those. I don't know where they are. They'll probably turn up. But the study, far from being a sort of a container for Darwin's work, was just really the central point of a sort of enormous virtual lab. His work spilled out throughout the rest of the house, overran the gardens, and went out into the surrounding countryside. The cockerels and pigeons and rabbits in the cook kept double duty as research subjects and dinner. There are experimental plants in the parlour and in the kitchen garden, a jar of worms on the piano at one point, and a series of actually state-of-the-art climate-controlled hothouses in the garden for studying exotic plants. His study, of course, was also where he wrote his books, but even then he was very far from isolated from the household. These are manuscript pages of On the Origin of Species at different stages. So, excuse me. So one in Darwin's, very much a draft in Darwin's handwriting with all the crossings out, and the other a fair copy with some of his late corrections. These are very rare. There are very few of these, fewer than 40, I think, in the whole world. And the reason why these survive, these are from the library's collection, Cambridge University Library collection. The reason why they survive is not because anybody thought that they were intrinsically valuable. If you flip them over, Darwin gave his used paper to his children to recycle for drawings. There's a fantastic collection, carefully preserved in Cambridge University Library, of Darwin children's drawings. So one of the most striking things about following Darwin's life is watching his children go from the subjects, being the subjects of research, as William was, and part of the environment within which his research took place, to becoming collaborators. 4 of them in particular played very significant roles. Henrietta, William, and Francis all sent home observations from plants when they were travelling or when they moved away from home. Henrietta and George both acted as editors and critics for Darwin's books, especially Henrietta. And George helped with statistics and maths, and Francis was was employed actually as his father's assistant for the last 8 years of Darwin's life. So it really became a sort of cooperative, a family business in many ways. And that started while they were still very young. Darwin described an experiment where he positioned several of his children at points in the fields around the house where he had seen bees pause along what he suspected were fixed flight paths. He was studying instinct. The children had to call out, "Here's a bee," whenever they saw a bee at one of their buzzing places where they were. And his hypothesis was confirmed as he heard the shout of "Here's a bee" sort of gradually moving across the fields as each child in turn shouted it out. Now, he never published this. This isn't work that he ever published. We know about it because it became relevant to the research that somebody else was doing later, and Darwin sent him details of it in a letter. Aha, okay. So that is Down House with the children. And the study shortly after Darwin had died, I believe. Let's let you look at that for a moment. And here are his experimental plants in the parlour, and also I think actually in the hothouse. The 2 smaller ones are the same plant in different phases of its diurnal cycle. This was for later work on plants that could actually sleep. So the bulk of the archive actually in the library is not, as I think probably most people would expect it to be, it's not manuscripts of his publications, and it's not experiment notes, though there are those, and here are some on his work on human expression. It's actually letters. Darwin never left Britain again after the Beagle voyage, and when he stopped going to the world had to come to him. And it was largely in letters that he shared and discussed his ideas. Letters brought comments and criticisms on his books. It's actually possible to see the 6 editions of Origin that were published in his lifetime as a dialogue with his correspondence, in part at least. Letters were an integral part of his working papers. Mostly what they brought actually was information on almost every imaginable organism from all over the world, plants, insects, animals, fish, and quite often more than just information. So still in the archive today, there are things like this: butterfly wings, photographs, which became a very important source of data for him, pressed flowers and parts of flowers, beautiful watercolours. There's a feather up there, but there's also actually on the letter at the back, you can just see, I think, 4 squashed bees, and they came from New Zealand. These are by no means the worst things that came to Darwin through the post, by the way. A diseased partridge foot, rabbits dead and alive, beard hair. I think that was one of the weirdest ones that we came across. They all had real, genuine scientific significance. So writing and replying to letters became a really significant part of Darwin's working day. For the most part, actually, they read much more like emails or text messages. They can be surprisingly informal. The first and perhaps sort of obvious point really to make, but one that gets easily lost in the Darwin mythology, is that he was far from working alone. Although he never met most of the many hundreds of people he corresponded with, they formed a sort of distributed research group, many of them. There are more than 1,500 letters written by and to Darwin that still survive. About half of those are here in Cambridge, and half are spread in collections all over the world. And we, the Darwin Correspondence Project, are publishing full transcripts with Cambridge University Press. And please go and look, just a bit of an advert. They are outside to look at afterwards. And we have a new one coming out later this year, so get ready to buy that. And this will be, we think it's going to be a complete edition, but actually letters still keep turning up, so we hope it will be a complete edition. We just published volume 22, covering the year 1874, and there'll be 30 volumes, as far as we know at the moment. And thanks to the collaboration of the press and the Darwin family and other copyright holders, they're also going online on our website. And you can see an increasing number of them, actually, alongside images of the originals, both through us and through Cambridge Digital Library. Now, it actually occurred to me when I was thinking about this talk that our beautifully designed edition, which we go to such lengths to keep in this uniform, gorgeous, totally the same every time format, has one drawback, which is that they all look the same. And I think that kind of uniformity masks the wonderful variety of the lives, really, that these volumes actually capture. That's another advert, there you go. Darwin's correspondence is a web of interwoven conversations through time and space, with people, just to pick just a few examples, with people as disparate as a German school teacher and political dissident who was in exile, more or less, in Brazil, a cantankerous Scot who lost his job at Edinburgh Botanic Gardens partly because he was spending so much of his time doing experiments that Darwin had suggested. Darwin got him another job, by the way. An extremely talented woman in South Africa who, when she wasn't holding down a homestead or off diamond prospecting somewhere, was writing up her really acute observations of tiny adaptations in grasshoppers. James Crichton Browne, who was the very young and very overworked superintendent of the largest lunatic asylum in England, who sent Darwin photographs and case notes of his patients. and about 1,996 others, because there are about 2,000 correspondents. And the longest running and most intimate set of letters was exchanged over a period of 40 years with Darwin's closest friend, the Kew botanist, Joseph Hooker, seen here on the Cambridge Digital Library site. They lived about 20 miles apart on opposite sides of London, and the postal service was so efficient at the time that they could actually send and receive replies to letters on the same day, which explains why it reads more like email often. And it was to Hooker that Darwin is first known to have revealed his theory of natural selection in writing, and you can see the letter on the Digital Library as well. Telling Hooker was what he had been up to was, Darwin said, very famously actually, like confessing a murder. Now, you can actually read that in different ways. Usually it's been taken as evidence that Darwin felt, at the very least, some degree of pretty strong anxiety, if not actually tortured, by the burden of his discovery. But seen within the wider context of the correspondence with Hooker, it actually smacks very much of a rather wicked sense of humour. And this is something I think that really does take people by surprise about Darwin. He did have a good sense of humour. One visitor described him, this was in 1868, as having the sweetest smile, the sweetest voice, the merriest laugh. And he was particularly good, she said, at laughing at himself. Although he was full of his great theories, he laughed more merrily than anyone at any flaw detected or fun made. If you've ever tried to read a 19th century copy of Punch, you'll know that humour doesn't really do time travel terribly well. You have to get your ear in. But there is a lot of humour in Darwin's letters, and the behind-the-scenes humour is a subtle corrective to some of the views we tend to have of Darwin. He's often portrayed as so reluctant to publish on human evolution, so concerned about the reaction he might get that made him ill. But there's actually quite a bit of light-hearted correspondence between Darwin and Hooker about natural selection and humans. I'll see if I can make this work. We'll see. You have to remember this was a very class-ridden society. So Hooker had been having trouble with the servants. And in reply to a letter from Hooker asking for recommendations for a trustworthy oldish cook, Darwin wrote, "We might have recommended the very woman, but she's going to marry. I wish to heaven natural selection had produced neuters who would neither flirt nor marry." So, good, you laughed. Thank you. And just to be even-handed here and spread the fun poking across the classes, Hooker joked about writing a book, which he said he was going to call "On the Principles Which Regulate the Development of an Aristocracy," which he said he'd have to publish posthumously. And it was going to have 4 chapters, each beginning with a B: blood, blunt, money, brains, and beauty. And he said these are all good things of use to the organism possessing them, and hence sought after by all human organisms, and their accumulation by natural selection must culminate in an aristocracy, or there is no truth in Darwinism. You're a very good audience. Natural selection, of course, is what Darwin called the mechanism by which he proposed that new species evolve. So where resources are scarce, small, heritable variations make the difference between life and death, and crucially, of course, between living long enough to breed and pass on those advantages to the next generation, or dying early and taking your less favourable attributes into oblivion with you. Given enough time, the different varieties produced would increasingly diverge. According to Darwin, a species was simply a variety where divergence had gone so far and in such a direction that its members could no longer breed with their distant cousins. It was a process that needed no more than a single ancestor to explain all the remarkable variety of life. Darwin is about the interconnectedness of all living things. When Darwin published this theory in Origin, in 1859, he was only 50, and actually most of his publications still lay ahead, with 8 major books in the next 22 years. And the rest of his life can be seen as a research program designed to, well, counter criticisms, for a start, and also to explore as widely as possible the implications of his ideas. We tend, I think, to focus on Darwin's achievement very much in terms of putting humans into a continuum with other animals. But also, of course, Darwin put animals, all animals, into a continuum with other living things, with plants. And today we know that we have, I think, 15% of our DNA in common with grasses, some grasses, 50% with certain kinds of nuts, and 60% with bananas, making us quite closely related to breakfast cereal, I think. but that perception of a plant-animal divide, I think, is still a really difficult conceptual hurdle. And much of the work that Darwin did after Origin was based on studies of plants, looking for ways to break down that perceived barrier, to wipe out that apparent boundary. In case any of you doubted that the Darwin Correspondence Project, my colleagues on the Darwin Correspondence Project don't earn our money, this is a letter from Hooker that talks about the aristocracy. His writing is even worse than Darwin's. But if you look at the bottom left-hand page, you can just see the word aristocracy. I think you can probably make that out. So this is his letter on aristocracy. And on the next page, you can probably spot a few capital B's, and that's where he's talking about the blood, blunt, brains, and beauty. So you probably recognize these. They're carnivorous plants, and these are some of the species that Darwin actually worked on. I think we are so used to the idea that these plants are carnivores, that they catch and digest animal prey, that it's hard to realize that this was completely unknown before Darwin demonstrated it. And the story of this discovery actually, it sort of has all the ingredients of a blockbuster. It's got beauty and seduction and deceit. That's how these plants catch their victims. And mass murder, tremendous slaughter, is how Darwin put it. And chloroform and cobra poison, amongst quite a lot of other noxious substances. But you have to go to Darwin's private papers, I think, to letters and notes, to get any real sense of that. You wouldn't ever really guess it, I think, from the book that he published, Insectivorous Plants, came out in 1875. It's a bit of a tough read. Unusually, I think it's the only one of Darwin's books that doesn't have an introduction or a general conclusion. The bulk of the book is a very detailed account of the experiments, painstaking experiments, that he did over many years on a range of plants that he suspected were carnivores. There is really very little in this that explains how dramatic Darwin's discoveries were, or that puts them in context. It has chapter headings like aggregation of the protoplasm within the cells of the tentacles, and the effects of nitrogenous and non-nitrogenous fluid on the leaves. It is worth reading, and you can read it. You can read it at Darwin Online very easily. I suspect it's not terribly widely read. And Darwin's contribution to this field is largely overlooked. And I think this is a pity, because this was cutting-edge science. And it's actually also cutting edge for us, because we've just sent the 1875 volume of letters to press. So we've only recently finished researching and editing the letters that now cover this whole story. And actually, if you do get interested in this, if you want to read more, I would recommend the introduction to volume 22, the 1874 volume, which is already out, because it's a really excellent way of getting into this. It's got some fantastic quotes from Darwin's letters. Darwin's adventure with carnivorous plants not only has the elements of a blockbuster, it also has all the elements of good science. Observation, curiosity and a questioning of orthodoxy, research, which you might expect, but he was a good research scientist, designing and refining experiments. Oh, good. Tenacity, because those experiments actually often ended up in frustration and blind alleys. Those are definitely things you don't see in print. Possibly more in this than many of the others. Collaboration. Collaboration in spades for this work on carnivorous plants. And it also really does have all the excitement of discovery, the thrill of the chase. And Darwin's, I think more with this material than with anything else that I can think of, Darwin's letters and notes are just scattered with underlinings and exclamation marks. If he'd had emoticons, they'd have been all over the place. And it started with serendipity. Like many scientific discoveries, Darwin's discovery of carnivory in plants was accidental. It started in the summer of 1860 when the Darwins were on holiday in Sussex. Darwin did not like holidays. He described going on holiday as an unendurable bore. His poor wife, Emma, insisted every now and then, she wanted to get him away from work, and so she insisted on going on holiday. In this case, it spectacularly backfired, because walking on the heath, he literally stumbled across a new research puzzle. He came across a colony of sundews, Drosera. The whole thing was, he said, an accident owing to my being from home and having nothing to do. And it sort of remained a holiday activity in some ways. He never really got over the feeling, he was a bit guilty about spending time on this particular line of inquiry. He constantly described it as a hobby. And he put the whole thing to one side at one stage because he said he really shouldn't be amusing himself with interludes. What struck Darwin most about the sundews, or first at least about the sundews at the time, was the fact that the tendrils move. You can see that one of them, half the tendrils in one have closed in over some prey, and they're all closed on the other one. And his work on carnivores was actually a sideline in a much longer study on movement in plants. Because one apparently obvious and sort of fundamental way in which plants seem to differ from animals is that they don't move. But Darwin showed that that wasn't really the case. It is rather, he said, that plants acquire and deploy this power, the power of movement, only when it's of some advantage to them. In other words, plants don't generally need to move for either nutrition or reproduction, for food or sex. And when they do move, Darwin showed that that movement itself is an adaptation to allow exploitation of otherwise inaccessible resources, such as anaerobic bogs, which is where many carnivorous plants are found, where roots are no use. So you have to get your food some other way. But something else that struck Darwin was just how many of the leaves of these sundews that he was seeing had dead flies stuck to them. He wasn't surprised that there were flies. This wasn't an observation. Anybody could have noticed this, really. It was obvious that flies got stuck. They got stuck to all kinds of plants. They certainly got stuck to this one, perfectly well known. But Darwin was curious about just why so many of these leaves did have insects stuck to them. He suspected that the plants might be adapted, very quickly suspected that the plants might be adapted to catching insects. And he wondered not just how, but why. And began a 15-year love affair. And it sort of went the way of most love affairs, really. Darwin and his Drosera, his sundews, spent every available moment together for the first few months. By the end of the year, he was experimenting on it. By the end of the year, he was calling it my beloved Drosera. But real life intervenes. He had another publication program on the go. And he started playing the field a bit, really. He had flings with other plants he suspected of carnivory. Venus flytraps, butterwort, pinguicula, pitcher plants, nepenthes. But actually, the affection for Drosera never went away, and 15 years later, he was still referring to it as his old friend. Darwin's son, Francis, wrote about his father. I mentioned curiosity. Francis wrote about Darwin that one of his characteristics was a special instinct for arresting an exception. Everybody, Francis said, notices a fact as an exception when it's striking or frequent. A point apparently slight and unconnected with present work is passed over by many almost unconsciously, with some half-considered explanation, which is in fact no explanation. But for Darwin, it was just these things that he seized on to make a start from. I put this together quite quickly, just looking through letters that are available online. Curious and curiosity were among Darwin's favourite words. He used them all the time. I had a sort of look at what we've got, and actually 1 in 7 of his surviving letters will have some variant of curiosity in it. It was both what motivated him, and it was sort of part of his working method, following up on those nudges, those things that piqued his interest. Very curious. How curious? Simple curiosity. I have much idle curiosity. It excites my curiosity. All of these, it's actually fun. But curiosity actually isn't by any means always seen as a good thing. John Ruskin, faced with Darwin's revelations on carnivory and plants, was amazed and saddened by how much that is abominable may be discovered by an ill-taught curiosity. And the same curiosity killed the cat originated in the late 19th century. So challenging orthodoxy takes courage. Not least, I think, the courage to risk looking ridiculous. Darwin thought that Asa Gray would laugh at him for his wild speculation at the time, that plants really could turn the tables and eat animals. And he described his work to Hooker as twaddle, and wasn't sure that it would ever be worth publishing. My questions were foolish, he once wrote, but not rarely. Foolish questions lead, I find, to good results. So to go back to 1860, the first thing Darwin did when he got home with all his sundews was a literature review. It was very recognisable sort of form of research. He got his botanist friends to tell him what was out there already in the literature, and actually it turned out to be not much. So he set about devising a series of experiments to test just what it was that triggered movement in the tentacles of Drosera. He tried putting all sorts of things on the leaves. I'm not going to go into massive detail about the experiments because that's the one thing you really can read in insectivorous plants. But it's a very impressive research program of constantly refining his methods. But to begin with, what he did was just raided his desk and then raided the rest of the house. And what he actually tried putting on his Drosera were bits of glass, cinder from the fireplace, stone, gold leaf, dried grass, cork, blotting paper, cotton wool, and hair rolled up into little balls. And also bits of raw or roast meat, boiled egg, fragments of insects, and spiders. And he was very quickly convinced that they were adapted specifically to catch insects, as he had suspected. And before the end of the year, so very quickly, he was also convinced that they were somehow digesting them. They could tell the difference between something good to eat and something that was not. The tentacles, just looking out of time, okay. Not only curled over more quickly when something containing nitrogen, something that they could benefit from, was put on them, but even more impressive, actually, they opened more quickly to release the things that did not contain nitrogen. He tried smaller and smaller quantities, and finally he got a friend in a laboratory in London to use the equipment there so that he could use increasingly microscopic but very accurately weighed and measured fragments. And then he tried liquids and solutions of various substances. By early September 1860, he wrote that he had tried water, syrup of sugar, starch, gum, olive oil, sherry wine, carbonate of soda, all of which contained no nitrogen and never caused any infection in the leaves. But milk, an infusion of raw meat, urine, raw white of egg, thin gelatin, thin mucus from the lungs, and saliva all caused powerful contractions, and they did contain nitrogen. Our Drosera, he said, likes milk better than any other drink. And Emma wrote, at present he's treating Drosera just like a living creature, and I suppose he hopes to end in proving it to be an animal. Well, yes, pretty much that's what he was doing. By the end of the year, he could write to Hooker, by Jove, I sometimes think Drosera is a disguised animal. And he speculated even more so really in his notes, does not eating flies make Drosera so animalized? He had two questions. We're up to the sort of tenacity point in my list now. He had two questions. Were the plants really digesting what they caught? And how were they moving? Even as late as 1874, some botanists were arguing strongly that even though they accepted that the insects were caught, they only benefited the plants indirectly. As the insects decayed, the fluids ran down and fertilized the ground rather than directly being digested. Some commentators were even still saying that they didn't think the flies were even caught and that they were actually just crawling in under the tentacles. And the other question, how were they moving? Well, he began to speculate that they might have something rather like a nervous system that transmitted signals from one part of the leaf to another and caused movement. But things didn't always go well. Hooker suggested that Darwin try chloroform to see if the plants were affected. So this was testing this idea of nervous system to see if the plants were affected in the same way as animals. And this is a bit of turning the tables here. Both Darwin and Hooker had direct experience of chloroform. The Darwins were early adopters of its use as an anesthetic in childbirth. And it was actually Darwin who encouraged the Hookers to use it. So here's Hooker now telling him to use it on his plants. Darwin administered it to Emma himself, and it was, he said, as composing to oneself as to the patient. But when he tried it on his plants, the results were inconclusive. So he moved on to a whole range of substances. Strychnine, belladonna, henbane, opium. Don't try this at home. Some seemed to act in similar ways and some did not. The opium actually put the plants to sleep. They weren't hungry after the opium. Darwin's work was actually always collaborative. I think that's something that the correspondence shows very clearly to some extent. But this is strikingly true in the case of his work on carnivorous plants. Hooker, who succeeded his father as director of Kew Gardens in 1865, provided him with exotic species, but he also put him in touch with his own network of botanists and explorers. And Darwin used old friends who just happened to be living in the right places, somewhere near a bog, really, to send him specimens, or actually sent them out counting the flies on leaves. You'll soon find out, he wrote to one of these guys, that I can be troublesome with a vengeance. Yeah. And Amy Ruck, who was his son Francis's new fiancée, told him about Pinguicula butterworts near her home in Wales. And she was immediately co-opted as a collector and observer. She and Francis spent part, at least, of their honeymoon in Switzerland actually looking for carnivorous plants. That's what it was like if you married into the Darwin family. Here are some of the things from the contents page of Insectivorous Plants. So it really is just a list of banned substances. Curare, and it does have the cobra poison in there. So this is Francis and Darwin's experiment notes on some of the Pinguicula that Amy sent to them. And you can see that it just actually was more or less reproduced then in his publication. Hooker in Europe, so it went beyond Darwin's normal network, really, because Hooker in Europe and Asa Gray, who's a botanist at Harvard in the States, put out pleas for help on Darwin's behalf. And all over the world, people were replicating his experiments. One notable researcher, I'll just mention one really, was Mary Treat, who was part of Asa Gray's network and who exchanged information with Darwin Darwin was so impressed with her, he encouraged her publication of her findings independently. She's well worth finding out more about. So, by the time he actually resumed his full-time work on Drosera, and this is actually more than 10 years after he first started, this is in the 1870s, Darwin had spent the intervening time working principally on human and animal physiology for Descent of Man and Expression of the Emotions, which were published in 1871 and 1872. And this is important because it had given Darwin new skills and new understanding. He was still learning. He also had access to a new network. This time it was anatomists and physiologists and biochemists. Some of these through Francis, who was training to be a doctor at the time. And so he was able to perform new experiments, or at least get new experiments performed for him, because really by this point his work had outgrown what he could do at Down. And so he began to inspire other people to do the work for him, the work that he couldn't do. Hooker was already studying Nepenthes pitcher plant at Darwin's instigation. But a new acquaintance, a physiologist, John Burdon Sanderson, began to perform the kind of galvanizing experiments that he had been doing on animals, so using electric currents to stimulate movement. Really, because of Darwin's inspiration, he began to do those experiments on plants. But actually, even when he was apparently working on completely different things, Darwin had never totally forgotten about his puzzles with carnivorous plants. And there's one particular item that I think brings this home. It's a book called Pathology and Physiology of the Mind. And Darwin was reading it in the 1860s when he was working on human emotion. And next to a passage which is actually about the nervous system of frogs, he's just written one word, Drosera. So he was writing on humans, he was reading about animals, but he was thinking about plants. By the time Darwin published Insectivorous Plants, the whole world really knew what he was doing. And in 1874, he was sent a newspaper cutting describing the discovery of a huge carnivorous plant in Madagascar by researchers said to have been inspired by Darwin's own work. He only realized it was a spoof when he got to the part where it ate a woman. He unwittingly started a craze, and man-eating plants sort of entered the mythology, and they're still going strong. Darwin himself never lost the sense of excitement, which is one of the things that makes the letters such a good introduction to his work. Enthusiasm is infectious. Following these new experiments, he told Asa Gray he had demonstrated that Pinguicula, the butterwort, was not only insectivorous, but graminivorous and granivorous! Exclamation mark. And when he told Hooker that he could now prove not only that Drosera was capable of digesting, but that it did so with secretions chemically very similar to those in animals, he wrote, "It's marvelous to see the blade of the leaf convert itself with the overarching tentacles into a temporary stomach." He teased Gray, who was always a little more reluctant on the sort of adopting the full force of natural selection. He teased him by using the language of animal physiology when he was telling him about his experiments on plants. The point which has interested me most is tracing the nerves. 3 exclamation marks, which follow the vascular bundles. By a prick with a sharp lancet at a certain point, I can paralyze half the leaf so that a stimulus to the other half causes no movement. It's just like dividing the spinal marrow of a frog. He carried on working on other kinds of movement, demonstrating how plants had adapted to climb, to twine, to fold up to sleep. And he's still begging for help, so he begged one correspondent, for the love of heaven and all the saints, to send him specimens of yet another new plant, and he signed himself, "Your insane friend." But Drosera remained his first and best love, and he was finally able to describe it not just as a wonderful plant, but as a most sagacious animal. I think he might quite like that as an epitaph for himself. The end. Thank you.